Yeah, it was. I put us out and then I'm like, I don't know what you're saying.
What's up? How did you?
Then she pulls up that 949. What?
Thank you. Which doesn't make any sense. Adam. Huh?
Study some, what's 9 cubes for?
Is it just cubes and squares?
What?
10?
Oh.
1 through 20? We got squares.
Oh, cute. 729.
Yeah, looking at your sheet over there.
But why do we be you do the number all plus your head.
Yeah.
That's simple math.
Yeah, it's not asking. It doesn't matter.
I feel like you have to memorize all of them. You can just like multiply.
So 125.
Yeah, we do that times.
Use a pencil.
10 cubes?
A piece of paper.
9 kids.
749.
I think that 13 is. I would do that right. It's not
343.
Whoa.
Whoa. Videotape?
You know, I don't understand that.
Okay, so, perfect squares. 6 times 6.
36.
What's 18 times 18?
What? 364?
Yes.
Really?
Yes.
Hey.
Sorry, sorry. Just oh wait, then anyone? Just us? Just us? Listen, who's got us?
16 squared. Man, you're struggling.
very important.
Alright guys, you are going to have exactly 3 minutes to do this quiz. These are perfect squares and cubes that we should be able to do within 5 seconds apiece, so it should be plenty of time. They're pretty basic, there's probably one tough one here, so. But they're all within squares 1 to 20 and cubes 1 to 10. So if you study those, they should be complete breeze. That's instead of
Free shows.
study problems.
I know you study already.
Yeah.
Yeah.
Actually.
Yeah.
That's usually good bet when you have quiz the next day. Alrighty, not too bad. So do we can go backwards from those perfect squares and perfect cubes to square roots and cube roots. That's pretty much what's happening back and forth. So when we're seeing those radicals now, we should recognize these perfect squares and cubes that we just did so quickly and be able to reverse that same process. So, alright, for right now, though, can you guys pull out your homework from last night, please?
Am I allowed to go up and do it?
Yeah, absolutely. Jump on the ones that I dropped there. Yes. Alright, let's get these guys up. Alright, so for these guys, we're listing what type of polynomial and what degree. What degree, I'm not just happy to see it over there. So that's what it asks for. Polynomial degree. I don't know if that was number 57. This is supposed to be 27. 27?
I did 57. I did
No,
57.
it's 57. Wow, I'm on page 507. No, it's not very fun. We'll go over it. It's all good. It's good when we go over the entire class, so it's pretty fun. Alright guys, so looking around the board here. So we're starting off with some polynomial identification here. So Cam's looking at y plus 3y, and he put the 3y in front and adds and has 3y plus y. He has it as a monomial, which doesn't make a lot of sense the way you outline it because you have two terms here right now. So you two terms are binomial, and then degree's great because we've got 3y to the first is there any way we can reduce this or simplify it or change it? We're not multiplying, so that was if we had multiplication. So for Ariel's guess, 3y times y, we would combine our y's and get 3y squared, but we have plus, so it's actually, we do have like terms here, so it's 3y plus 1y, which gives us 4y. So you're right on the idea that it's a monomial, and it is first degree, but we can't simplify it to 4y. Good there? 18 looks good, so Connor combined the like terms, so we have 11x squared and negative 7x squared, so we got a positive 4x squared. And the last two terms are still there. So we have three terms, an x squared term, an x, and a constant, so we have a trinomial, and our highest degree is 2, so we have a second degree. Marins, negative 8y squared and positive 8y squared cancel each other out. One thing we can do here, descending order, if you want, we can put this 2y to the third out in front. You do have the right pieces involved here though. In what degree would we have them? It's a little easier to see when it's in descending order. So if we rewrote it as 2y to the third plus 4y, what would be the degree for this binomial? 3. Because again, our exponent for our leading term, our highest degree is 3. So it's 3 degree. Jordan's, so again, this is one of the evaluating for polynomial problems. So what Jordan did is we have the function p of a, and it has in terms of a right there, and then now we want p of negative 5. So everywhere he could, he took negative 5. It's always nice to use parentheses. He did around everything except this one guy. And then just solve, or simplify. So put negative 5 in here, here, and here, everywhere you see an a, and then just simplify all of the way that you can. So that one looks great. So negative 28 is our answer for that guy. One thing I want to note for you guys when you get your homework, I do have something to pass back to, is when we're asking you guys to take notes, it's not just X out or erase the old answer and put in the new answer. It's trying to make a critical note for yourself. Like here I forgot to multiply two terms. I should have FOILed the last term. I could have tried to reduce here, try and make a mental note, and also write it down to yourself. So maybe when you're going back over before you study for a test, you can look at that little piece there and then try and capitalize that when you're actually making your last second adjustments. So I'll try to make note of that too on your homework rather than just writing down the new answer. So Nikki's looks pretty good right here. So she reduced everything through. We could also write like we were yesterday. So 2x is being divided into 4x squared plus 6x minus 3. Either way it works. This one with the monomial is pretty easy to work out just this way, since you can see that we have 2, the 4 divided by 2, x squared divided by x gives her 2x. Same here, 6x divided by 2x, got a 3. And then these guys actually reduce out there because we have x over x, which is just 1. So this would just be 3 right here. And then right here, as our remainder, we have a negative 3 over 2x. And I was just wondering, is this a 5, Nikki, or a 3? I just couldn't tell.
It's a 3.
Alright, yeah. I thought so. So yeah, and then we end, our remainder is negative 3 over 3x over 2. Negative 3 over 2x. So if we're still having trouble with that, that's a new one, so we'll keep working on that. So 10 over here, Carrie broke it down, rewrote it here in long division form, and ended up with 3x minus 2x, I'm guessing, plus x over x squared. Can we reduce x over x squared? Just using the rules that we learned before about exponents. So we have x the first over x the second. So yeah, it gives us x to the negative 1 or 1 over x.
Yeah.
So x to the negative 1 or 1 over x. So we'll just reduce that here. So 1 over x. Everyone see that move that we just made right there? 11. Some more division. So again, rewriting it, looking at it long division wise. For when we start to move in binomials, this is the most effective way to do it. So 6x cubed minus 9x squared minus 3x. So So we worked it all the way down, dividing 3x squared into our trinomial right there, and ended up with 2x minus 3 minus 1 over x. So he ran the same exact situation where he had an x over x squared, and he was able to reduce it to 1 over x. So that's where this piece came from right here. And then last one, we'll look at this as a class. So I'm going to put this up on the board over here. This is great. This is one of the word problems that we've been working on. We've had a couple, and we'll have some more. I have one also ready for class today. But let's try and work through this together. So we'll note the most important thing that needs to happen when we have subtraction going on. So from the sum of, or subtract 3x squared minus 4x plus 2 from the sum of 4x squared plus x minus 1 and 6x minus 5. Is that the problem you guys all had for that one? Okay, I was just double checking. I didn't have a misstep there on what I posted. So, I'll write out these. So subtract 3x squared minus 4x plus 2. And we're subtracting it from, so paying very careful attention to it. When you want to, underline words that help. You know, we're subtracting this guy, and then, it's very few words in this case, but they all count for something. So from the sum of, so noticing it says the sum of, and then the next two ones that are coming after the one that we're combining are off of that when we're adding. So 4x squared plus x minus 1 and 6x minus 5. So how do we want to set this up? Lauren, looking at this thing now, since we have a different problem, how do you think you want to set up? So it's saying subtract this guy from the sum of those guys.
First I would do the 4x squared plus x minus 1 and add that to the 6x minus 1.
Yep. And anyone want to help her out? So what do we get there? So plus 6x minus 5, or you got it?
4x squared plus 7x minus 6.
Minus 6. Everyone good so far? Are we good to you?
And then subtract that from 3x squared minus 4x.
So is there any way that you want to be clear in how I should write this down? Do I need parentheses? Do I not need parentheses when I'm writing this next piece down?
Yes.
Thoughts on that? I'll just throw some around here anyways. It's just nice to continue keeping parentheses. So this next one, then open parentheses and go from there? Okay. Do you think we need it? Is there a difference? Does it make a difference?
Yes.
Over there, back corner. You guys think so?
I would put it like how you would do it, like regular subtraction.
You
like
can absolutely do that too. So you're saying like this,
top
but you still need parentheses when you're doing that too?
Yeah.
You don't. Let's see what happens in that case. So minus 3x squared minus 4x plus 2. Yes or no?
I guess so. Yes.
Absolutely. So the reason why, you can absolutely stack them like this. That's a perfectly fine way. You can line up your term. That's a nice way to look at it and visualize it.
Yeah.
The thing is, this parentheses then make sure this negative sign is going to the 3x squared, also to the negative 4x, because then it'll make this positive, which changes this guy. And then also the positive 2. So we'll leave this there. I'm going to rewrite over here just side by side. So 4x squared plus 7x minus 6 minus 3x squared minus 4x plus 2. So is that how you end up going through that, Lauren? Yep. Did you want to give your final answer? Just so you know. Alright. So we'll break it down. So 4x squared. Want to combine all those guys, try and pull out like terms for me? Can anyone help her out?
Alright,
We'll finish with it.
negative 3x squared, 4x squared.
So,
We'll just do x squared then.
we'll x squared, because we're in terms of x squared. So we got like terms, we have 2x squared terms.
And then you
So-
got 7x and 4x
Yep.
equals 11x plus 11x.
Yep.
And then you have 6x and or negative 6 and then 2 equals negative minus 8.
Sounds good. So So again, the most important thing in these problems, guys, is doing your best to break down the words that are going on, set up the right order, so realizing you have to sum these guys, add them together, and then we're subtracting this from the sum of those two guys. So working through it, you can even draw lines, kind of block out pieces if it helps you when reading the English, and do the operations that you need to first, and then again, making sure you use parentheses in these guys. It's very key. So because the parentheses, we're not just subtracting as 3x squared, we're subtracting everything. So that's why the parentheses are necessary. So make any last second corrections to your homework, notes, not just erasing all the answers and putting them in, and then send those in, please. I gotta pass out some old stuff to you guys. Yep, I'm ready, man. I'll be there.
How did the game go last night?
We got 10 run, but it was a good game. A lot of positives again. It's tough. We just have a lot of pitchers who aren't even in the game, so.
Did you guys play John Glenn?
Yeah, I'm gonna go into John Glenn. So it takes a little while to adjust for those guys. It's good though. This one's really good. Yep. Yeah, no problem. Don't worry about it. That looks fine.
They were losing. That was here last night?
No, I mean, it's not some questions for me. You guys help me out.
Like what I did, this is number 57. I tried just figuring it all, not realizing there was like terms right now, like a note of like terms that I need to find out. And I just redid it. And I said like I need to find like 27 and I can do it. Like I don't know why I did that. It took me like 10 minutes.
Right, so what you need to recognize is that this is addition, not multiplication.
Along with
So that's the first thing. When you see a set of parentheses, don't automatically assume it's multiplication. So you gotta really pay attention to what's happening. It's asking me to add these, so when I add, this is what I need to look for. Right?
Fine. We can stay.
Yep.
Alright guys, so again, I didn't mention yesterday, but it should be to no surprise that we have a test tomorrow. It should be a half period test of 40 minutes. It will be. I had on school duty for a couple days now. I will list all the sections tonight, and it's nothing out of the ordinary. So radical stuff that we were working on yesterday, we had a quiz on, polynomial work, and one big thing, as it is in all math classes, our tests are cumulative. So old things come back to you, which is why I have a few review problems for us here today too. So we have 15 minutes, we're just going to keep going, and I want you guys to work individually for about 30 seconds or a minute, and then talk over your group, and I'll call on someone to try and answer these questions correctly. So I'll put the first one up here as I continue to erase. So first problem. A little bit of a throwback here. 6x squared y to the negative 2. So two sides. Well, I work with an exponent first on the left hand side, and then moving over. Remembering algebra. I'm sorry? No, it's 5 to the negative 1, and this is just a positive 5 down here. Positive 6, we got a 2 for our exponent outside that piece, and these guys are alone. No exponents. What's that? Oh, okay, yeah. It doesn't really change it, but working on it? Yes. Sorry, I'll make that one. So we've got 6x squared, y to the negative 2, and then that's all over 5xy, and it parentheses around that entire piece to the second power, and then 5 to the negative 1, x to the third, y over x to the negative 2, y to the negative 1. So take 30 seconds, 40 seconds, try and work through it. Don't rush because you don't want to make mistakes too. Be careful with the negative exponents, and then we'll take a peek at it. Finish with that one. What we rows are finishing up. Here's the second one. I want you guys to start on. 20. On one side, I'm calling a group here. So you guys a little bit talking. Do try and talk to that person. Let's see if you have anything similar, anything different. You feel confident about it. And I'll ask someone about that. If you guys are done talking, take a peek at this, and then we'll get the answer for the first one here.
What?
Did you guys have agreement on that first one? Oh, okay, I'm so far, yeah. You're missing some stuff. Negative exponents is y to the negative 4. Start one negative 2. No, sorry, extra. Oh. Okay. Alright guys, let's look through that first one. So,
I got this.
what do you think, Dan? What do you get for an answer? I'll put up your answer and then we'll look through it.
36
Yep.
x to the 7.
36 x to the 7. what I have. That's what I has. Everyone else? Is that what we all got? Now let's take a peek at it.
Yeah.
Yeah, the only thing I different is on the bottom.
Not quite. Alright, let's quickly look through it though. So I'm just going to translate it down. So 6 squared, we have 36. Right here. Again, we're going to all these. We have x to the fourth. 2 times 2. Positive 4. Y to the negative 2 times 2, so y to the negative 4. Over 5 squared is 25. X to the 1. Now raise to the second power is x squared. And then same with the y. And then over here we have 5 to the negative 1, so that goes to the denominator. So you now have 5 down here. Again, this is not the negative 5. It's not coming out in front. 5 to the negative 1 equals 1 over 5, which is why it comes down here to the denominator. And then we have x to the third, y to the 1 if you want to put that in there. And then x to the negative 2, so we can bring that guy up. Again, negative exponents, so now it's positive x to the 2. Same with the y to the negative 1. Bring that guy up and we have a y to the 1. So moving over one step, we have 36 x to the fourth, and then our y to the fourth goes down, so 25 x to the second. We had 4 y's that are coming down, so y to the sixth times x to the fifth, combining these guys, y to the second. Over 5. So multiply the coefficients. We have 125 on the bottom over x squared, y to the sixth. And then we have 36 x to the fourth times x to the fifth. Again, we just add our exponents, multiplying across. So we have 36 x to the ninth and y to the second. So once we get here, we're not quite done because we can reduce these guys. Quotient rule. We have 2 up top. We can take 2 away down here, left with 4, so y to the fourth, and then take 2 away, we're left with 36 x to the 7th, 125, y to the fourth. Alright, looking at the next one now. Any questions on the last one? See, I know it's quick work, we're just really short on time, I want you guys to see more review. So try number 2. So back to the radical stuff. Got it? Should be pretty quick these days, especially since we're just working on our perfect squares and cubes. I know it's fresh in your minds right now. There you go. Hey, especially if we're having trouble with that, there's a great note card for you since we're allowed to have note cards in the test tomorrow. Note card on our squares and cubes. Yep. Gotta rescore these. It's in there. I like it. There you go. Add to it too, especially on the new stuff like that.
Yeah.
Alright, are we done? Thumbs up if you guys are done. 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 Done over here. This group's together on their answer. Almost done over here.
he's done.
Take one more minute. Okay, good. Pop it out.
Hey, you guys done?
It's not effective. Maybe see what they got and talk about it. Alright, so while they're finishing that one up, we're going to put another one up on the board. X squared plus 2 all squared. Gotta do it. Good practice.
Oh,
New
there's
one.
another one, okay, I didn't see that.
Oh, was that number 3?
Yes, sorry, I put it next to it. It is number 2.
I feel like we went over this yesterday.
Absolutely. We gotta keep it fresh. We got tomorrow on the test. Board rule.
Like, so you know. Oh, that's just
Squared, okay.
Oh, wait, no, I don't even need that, right?
Yeah.
And
You just
so you break the like terms. So like I went from there to 5 square root 2.
So we got. Alright guys, again, I'm going to make one quick note, sorry, I don't mean to cut you off, but, so I like the idea of having you guys do a type of factor tree with your square roots, but you guys tend to make a lot of mistakes, because you can't really just write 5 and 4. Factors of square root of 20 are not just the numbers 5 and 4. You've got to start putting them like this, side by side. I feel bad because I let you do that factor tree, but I was trying to make it clear that big difference. Because you end up missing a lot of pieces looking at your homework. Try your very best to write the radical multiple times, because now you can see we have radical 4 which you can work with, so now Cam said 2, radical 5. Now looking at the next one.
Minus 3 square root 3.
So we have minus from here, and then you break it into, again, both radicals, square root of 9 is 3, and then we still have the root 3, plus
Plus 7 square root 2.
root 49 times root 2. Reason again, because you go backwards, now you go back up, so it's becomes 7 root 2, and then last one, Cam.
Plus 2 square root 3.
Nice work, I see you looking on your paper, nice work, Lynn.
Oh,
Good work, both of you guys, though. So root 4, root 3,
That was my
This
word.
is
I
a
gave it to
oh,
her.
you gave it to her, alright, I just said in front of her. No worries, you
And
guys
then,
are both working out, so 2 root 3. And then everyone looking at this guy, do we have like terms anywhere that we can combine?
the negative 3 and positive 2 would be 2 square root 5 minus 1 square root, or just square
So
root 3
2 root 5, what's the next one, sorry?
minus square root 3, because negative 1 negative sign just makes it negative.
Yep, exactly, so we have negative 3 plus 2, so we can put a 1 in front if you want, but just root 3 would do the job perfectly well.
And then plus 7 square
And
root.
then plus 7 root 2. And we're all done. We can't combine anything else, no more like terms. Again, we combine the coefficients, but we need under the radical to have a like term. And now we have 5, 3, and 2, so good there. Moving on to the next one. Got it? Alright, I'll put up another one. They gotta work on it right now. Yes.
This isn't like the right.
So you gotta remember to do a complete 4x. So here, remember before we were going x squared times this, or 2 times this, 3
Oh,
times
oh, okay.
How do you guys feel on number 3?
okay.
I didn't see what you had. Except when we combine these, 2x squared plus 2x squared.
Oh, equals square.
Exactly. Yes. What, you got it already? Okay. So before I get answers from somebody, what's the next step when we have this binomial, in this case, squared? How do we rewrite this next?
Parentheses x squared plus 2 parentheses twice.
Exactly. Again, squaring is saying we're taking this thing 2 times. So x squared plus 2. And now again, anyone want to rewrite it one more time? I was having you guys do it yesterday because I think it's a little easier to look at. Addie?
Oh, x squared and parentheses x squared plus 2
So x squared parentheses x squared plus 2, and then the second part
is 2 parentheses x squared
plus 2 x squared plus 2. Again, might take a second to let it sink in, but this is the same exact process that we're doing since we're taking x squared, we're multiplying it by x squared, taking x squared, multiplying it by 2. X squared by x squared, x squared by 2. Same thing. Again, 2 times x squared, 2 times 2. 2 times x squared, 2 times 2. Just a different way to look at it. A little easier distribution than doing them side by side like that. So what was our final answer for that one? Alex, you get this one?
What, for that?
You had an answer, you guys over there?
Well, not yet.
Alright.
Yeah.
Connor, what do you think, man?
X to the 4th plus 4x to the 2nd plus 4.
Alright. So we've got our x to the 4th. And then we have x squared times 2. So we get 2x squared. Moving over to the 2 now. 2 times x squared plus 2 more x squared. And then 2 times 2 is 40. And you combine these like terms. So again, when we're adding these guys, we don't want to add our exponents. We we have a like term of x squared, so we can add the coefficients out in front. So carry this down, and then we get now 4x squared, so plus 4x squared plus 4 to finish. Great stuff. All right, everyone working on 4.
So that's simplifying polynomials.
Alright, if you're done, move over here to the last problem before I have to let you guys go. Big one over here. So if you have time, take a peek because we're going to go through it very quickly. Anyone have a final answer over here? They feel pretty good at that? I'll take a peek before. Only thing is you wrote the sign wrong, so it's x squared. Oh, I wrote it wrong. I'm sorry. That's supposed to be a multiplication sign here. 4 through was what you have. So we'll go with negative sign. I meant to multiply those. And let's see, looking through your work. That's my fault. Look like a negative sign. So there's x to 4. Nice. X squared. Yep. Here's 4. Alright, we'll go over this one quickly. Alright, so I wrote this wrong. You're very close. So we have 1 minus, again guys, this is the exact same type of thing as the word problems. We have a negative sign outside these guys, so you have to make sure to distribute the negative sign to everything. Right, and then 1 plus. So it would be 1 plus 4, and then minus. Okay, so again, last thing I'm trying to make a note of. So again, because this negative sign is outside of everything, right here, it's a negative x squared. It's a positive now 2x to the third. Now it's a negative x to the third. And then all the way through, you combine them. So the one thing, guys, cube root of x to the 7th, y to the 4th, you have to remember we're still looking for groups of 3. So x to the 7th, we can write as x to the 3rd, x to the 3rd, x to the 1, y to the 3rd, y to the 1. And we can bring all the groups of 3 outside the radical. So 1 group, 2 groups, you get x squared, y, root of xy. Because again, these guys are left, we all got groups of 3 there. And then remembering guys, last thing I'm going to note, again, have questions tomorrow, ask me questions, I'll be here after school. Pay very close attention to cube roots versus square roots, it makes a drastic difference. So, keep working on it.
I am not going to say 4, so I don't have to do a little bit.
4s?
4 period.
Fourth period.
I can have to do a little bit too.
We'll see how it goes for you. And I'll do it.
Usually they go really fast.
So we'll see. Yeah, you gotta go get it.
Wow.
Yeah. Yes.
Yeah, you can come if you want.
So we come up with a balcony.
Yes.
Yeah. I think we're gonna get rained out, but yeah.
I'll show up. I'm going to put up